Hi everyone, students. In today's lecture, we will discuss that how do stars form. You know that in the previous lecture, I have discussed about the formation of a protostar, but in today's lecture, we will discuss about the formation of a star from a protostar. Protostars are not yet hot enough to sustain fusion reactions. In order to become hot enough to sustain fusion, protostars must gather more material and squish it. Material surrounding the protostar feeds down onto it. And at the same time, gravity continues to slowly squish this protostellar material into smaller and smaller regions. As the protostar contracts and heats, the fusion rate increases. And the heat generated by these nuclear reactions provides a pressure force that slows the contraction caused by gravity. When the core temperature of the protostar reached about a million Kelvin, the winds generated at the protostar surface blows the surrounding gas and dust away. That is actually the end of the accretion phase. This figure represents the winds that is generated on a protostar surface. Now, without its source of additional material, the protostar continues to slowly contract and heat until the core temperature reaches 10 million Kelvin, at which point the fusion becomes stable and we have a star. As represented by this figure, that the fusion is stable now. Fusion rates become stable because the force in the interior of a star becomes balanced. Nuclear reaction rates are now high enough that they produce the necessary heat and pressure to prevent the star from collapsing further due to gravity. When the gravity and the gas pressure forces are in balance, we call this state hydrostatic equilibrium. The net force on material within the star is zero. The star can remain stable in this state for billions of years. Our sun is currently about 5 billion years old and in a state of hydrostatic equilibrium. It will remain stable in this state for another 5 billion years. Now we have a star. Students, in today's lecture we have discussed about the formation of a star from a protostar and its detailed explanation. This is all about this lecture. Thank you so much.